Dear ladies and gentlemen, my name is Anna Schieben. I am leading a team of human factors and HMI experts at the German Aerospace Center in Germany, and I was acting as the coordinator of the interACT project. I'm happy to present you today the results of the project that we achieved during the runtime. So first of all, some project facts. We were funded under the Art 04 call Safety and End-User Acceptance Aspects of Road Automation in the Transition Period, and we started in May 2017. Due to the COVID outbreak, we had to extend the project slightly for some months, so the project officially ended in September 2020. We had a nice mixture of academic and industrial partners in our consortium. You see them on the right-hand side coming from the UK, Germany, Greece and Italy. And we were twinning with AV Intent from the US-American NHTSA funding program. So first of all, let me introduce what our challenge was. In the traffic situation today, you have the onboard driver on the one hand side and on the other hand side other traffic participants. And you might know that from your own driving experience. Sometimes we are using hand gestures, eye contact, so we are interacting among the other traffic participants. And the question is, what happens if automated vehicles are introduced into our future environments? So the challenge here is that the vehicle automation for sure will play a central role. On the one hand side, to interact with the onboard user, so what is on the display, how much transition time does he have, but on the other hand, and this is quite new, the interaction with other traffic participants. So how do other traffic participants know what's going on and how the vehicle automation will behave? And this was especially what we worked on in the interACT project. So we defined 5 enablers to achieve a safe, highly accepted and efficient integration of automated vehicles in mixed traffic environments. First of all, we wanted to learn more about the psychological models. So what's going on in human-human interaction? How do humans behave currently when they interact in real traffic environments? Secondly, the automated vehicle itself needs to know more about what is going on in its environment. So we worked on improved intention recognition algorithms and the behavioral prediction of other traffic participants. And our third enabler was the so-called CCPU, the Communication and Cooperation Planning Unit, including the safety layer. This is more or less the central intelligence of the automated vehicle, where everything is calculated, coming from a situation assessment and then going into the calculation of the trajectory for the automated vehicle and a timely synchronized eHMI and onboard HMI trigger. The fourth enabler is about novel HMI elements. So what kind of HMI elements, especially for external communication, do we need for automated vehicles? And the fifth enabler was about the methodology for assessing the quality of interaction. Today, I'm proud to present you the results of all 5 enablers, and I think it's best to watch a video where we summarized all the results and where you see our 2 demonstrator vehicles running and in interaction with other traffic participants.
Automated vehicles are likely to be deployed soon in mixed traffic. For this, the interaction of automated vehicle with pedestrians, cyclists and other vehicles needs to be safe and efficient. In today's traffic, drivers use multiple cues such as gestures, verbal communication, vehicle signals, or even eye contact to interact with other traffic participants. Therefore, automated vehicles need to substitute this human-to-human communication to ensure an intuitive and safe interaction. The interACT project aims to safely integrate the automated vehicle into a mixed traffic environment. Through the interACT solutions, The automated vehicle is able to understand the intentions of other road users, plan its trajectory accordingly, and communicate to road users in real time. For example, the automated vehicle can identify a pedestrian's intention to cross the road. It can then react by reducing its speed, signaling its intention to stop by specific light signals, stopping, and giving right of way to the pedestrian. The researchers of the interACT project observed how humans interact in real life when participating in different traffic environments, and from this, developed socio-psychological models. These models were used to improve the decision-making of the automated vehicle when moving in real traffic conditions. Further, the developed socio-psychological models helped the interACT researchers to improve vehicle sensors and data processing algorithms for the AV's decision-making when moving in real traffic conditions. The brain of the interACT system, the Cooperation and Communication Planning Unit, CCPU, collects all the traffic information from the environment and the machine. Therefore, the CCPU is able to predict the future behavior of each detected traffic participant. From this prediction, the CCPU develops a safe trajectory by using the developed safety layer in almost real time. Taking the planned trajectory into consideration, the CCPU also triggers the external and internal HMI to communicate the planned activities to the involved traffic actors. As a result, the CCPU ensures that vehicle movement patterns are matched with the messages communicated via HMI, which leads to an avoidance of collisions and other types of accidents while moving in real traffic. The communication of the automated vehicle with the other road users is achieved by novel human-vehicle interaction. Two types of external HMI have been developed with the interACT project: the 360-degree light band directed signal lamp. Furthermore, a perception signaling design and an intention signaling design were developed as two different interaction strategies using these novel HMI components. The project's researchers developed two specific demonstrator vehicles, one from BMW Group and one from central researcher Fiat. The developed components, including sensors, CCPU, and eHMI, were installed and implemented into the demonstrator vehicles. The fully working demonstrator vehicles were used for the final evaluation of the developed interaction strategies. To achieve this, a mixture of test track and real-world studies were performed with external participants. The interACT solutions will foster and increase social acceptance of AVs by improving their ease of use, road safety, and traffic flow.
I hope you enjoyed the video. Let me summarize the main results. interACT solutions were developed, implemented, and evaluated in our demonstrator vehicles with promising results for a safe and well-accepted integration of automated vehicles in mixed traffic environments. The technologies that we dealt with in the project were developed from TRL level 2 up to TRL level 6, for example, the 360-degree light band and the directed signal lamp. During the project runtime, we were also in intensive exchange with the standardization bodies, for example, the ISO, GTB lighting groups, SAE, to ensure the full use of the project results. And industrial partners will further work on market introduction for the main technologies of the project. So you won't be surprised to hear that further research is needed. We didn't cover all. For more complex scenarios, for example, for different vehicle types, further user-centered evaluation of the technologies, and, for example, needs of special user groups. I'm happy to say that follow-up activities are partly integrated in the new EU-funded HyDrive project, but we are currently also searching for new funding opportunities on international level. Having this said, I would like to make you aware of our interACT homepage, where you can find the results to date. There you can find all deliverables of the project, and if you are interested to hear and watch more, you can check our final event section, where you can find all videos taken during our virtual final event and download the PDFs of the work package presentations. And I've copy and pasted the link of our brochure for a summary of the results of the project. Having this said, I would like to thank you for your attention. Thanks.